Our last topic in section 2.3 is the intermediate value theorem. It's in this section because the intermediate value theorem is only guaranteed to work on a function that is continuous. But here's what it says. If a function is continuous between a and b, so those are x values, a and b, then that function has to touch every y value between f of a and f of b. So think about what it means. Because we know a continuous function doesn't have any holes or any skips, if you have a favorite y value, the function's going to have to touch that favorite y value as long as your favorite y value is between 2 points that we know on the graph, because there's no jumping and no skipping. So watch this next slide. So this is the same picture. We have the second sentence that can help us understand a little better. So suppose k is any number between f of a and f of b. So for me, k is a y value that I like, a y value that I care about. And I know whatever the y value is there and whatever the y value is there, I know the k, the y equals k that I picked, it's between those two y values. You can see because this function doesn't do any skipping, there has to be some place between a and b so that if you plug c into the f function, you get k as your y value. So let's see what that would look like on the AP test. Here's an example problem. I'm going to recommend highly that you make a graph to go with this problem. So it says f of x is a continuous function, so I know the intermediate value theorem holds. I know that f of negative 1 equals 2, f of negative 1 equals 2, and f of 5 equals 4. Oops. F of 5 equals 4. And their question to me is, can I guarantee that there's a value, an x value c, whose y value is 3? So watch this. My recommendation is that you come in here and you graph a horizontal line at the y value that they've asked you to care about. There you go. Now ask yourself, if I connect those two orange dots with some kind of continuous function, is that function I draw going to have to cross the red line? And the answer is yes, it's going to have to, because I know that I have one dot below the horizontal line and one dot above. So that's what I use to make a statement using the intermediate value theorem. So I'm going to try typing this in so you can see how you have to give your answer on the AP test. The answer to an intermediate value problem is always going to have to be phrased in a complete sentence. And remember, we can only guarantee the intermediate value theorem works if the function is continuous. So that's how we start. Give me a second, we're going to try this out. So I start my statement by promising that f of x is continuous, because I'm going to use the intermediate value theorem. And remember, the reason that I'm so confident my function will cross that red line is because I have one dot that's above and one dot that's below. So this is what this looks like. So here's the part where I say I know I have one endpoint of my function that's above the y value I care about and one that's below. So I say the one y value I know about, f of negative 1 equals 2, is below the y value I care about. So I would say f of negative 1 equals 2, which is less than 3. And f of 5 equals 4, which is greater than 3. So now I've established I have 1 point below and 1 point above. And this is the good part of the intermediate value theorem. It can guarantee that there exists an x value. So we're going to call it c, because that's what we called it in the problem. So the intermediate value theorem guarantees that there exists c. C has to be between a and b. So we say a is less than c, which is less than b. And then here's that final statement, and that the c value that exists, it meets our original requirements, which were they had to have a y value that was equal to 3. So the intermediate value theorem guarantees that there exists c, a is less than c, which is less than b, such that f of c equals 3.